evening, good evening, good evening. Good evening, ladies and gentlemen. Good evening. WeatherBrains episode number 983. 983. This is the pre-show. And I think you know what this is. It's the magical part of the program where we typically do three things. We share boring personal stories, humorous anecdotes, and we say outrageous things. All right, let's get this sucker going. If you're looking for the actual show content, move the slider over about 9 minutes and you'll find it there. But you never know what you might miss in the pre-show. This part is not on the audio podcast, the produced version. So sometimes you miss some good stuff here. And this is only for our YouTube viewers. YouTube.
Yeah, James fan, you would miss the delicious dinner I cooked.
Hey, let
How
me
about
get my
that?
old man glasses here.
Old man glasses. Is that
So
what we
what
call
what
these now?
what what do we have here?
It's chicken with rice and broccoli and cheddar cheese and
That actually
scallions
sounds
and
that actually
bacon.
sounds pretty good.
I actually gonna be pretty good, I think. So I was in charge of dinner tonight. But it was supposed to be ready at 5:45, but of course it was ready at 6:40.
Hey, 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 better late than never. Come on now. Uh,
Me and this lady
oh,
were fighting over the last three chicken breasts in Publix last night.
wow. Hopefully somebody got that on the talk. It's got some video there. I love a good brawl in the Publix. That's good. Um,
It was a civilized fight. She was like, "Well, it looks like the chicken is picked over. Like, you take it. No, you take it. No, you take it. Okay, I'll take it."
what's weird, we were actually in a Publix. I play tennis every Sunday evening. And often after tennis, we will go get a few things at the Publix. And we were there last night, but we didn't fight over chicken. Um,
Mine was the one in Vestavia, though, so probably not the same one you were at. It
all
was pretty picked
right.
over. I don't think Sunday afternoon is the time to go to the store. 5, 6 o'clock.
So there's our
Ooh.
active weather to the west of where we are. It might be to the east of where you are. But little rain and storm action in Louisiana this evening.
At least all
And
the
so
tornado warnings are gone.
we've lost some of our regulars due to we lost Rick Smith due to weather. I think he might pop in briefly. Rick had to do some storm surveys. They had some pre-dawn QLCS type action. Um, so some guy posted on the Twitter and one of these things. Hey man, you know you're in Oklahoma when you got tornado warnings at 4 a.m. Wanted to say, hey man, move to Alabama, you'll get them all the time. I mean, it's like that ain't nothing new here, pal. Um, but anyway, Rick has been doing some storm surveys, so I think he's out, and Kim is at the emergency management. What is this thing, James?
The International Association of Emergency Managers, maybe?
Very important. It's international. That's
Ooh,
much more
Very.
important than
where is this taking place? Doing
Colorado, I think.
Ooh,
Denver,
that
Boulder.
sounds. Are they getting snow?
Ooh,
Are they
I
going
don't
to get
know.
snow?
People are actually at the conference in session, so probably not. Because if there was
There's a
snow,
little bit
then
of
I'll
snow.
be,
A little bit of
wow.
snow in western Colorado.
now,
I just
Jen's going to be getting some snowflakes up there. She's getting ready for the snowstorm of the century late this week. She sent me a note and she said, I'm getting ready for the snow. Um,
amazing. Yeah, we haven't even had a freeze here yet.
wow.
Yeah, we haven't either, but that's not unusual for us, I guess.
I think November 3rd is our average first freeze.
Most of my TV markets had a freeze, but as always, the
The
official
airport has them. Yeah.
observation is a urban heat island type thing, and it doesn't count.
Are
But
either one of
most
you going to AMS in January?
that's the hardest time of the year. I don't have an open date to do anything like that until 2026, late 2026, because of these school visits I do. And it's just hard to make that when we typically we have active weather, something's going on. The NWA is much easier because it's like kind of, right before the schools are going. And I will be in Huntsville for that one.
I just hate to miss Oklahoma in January. That's why I always stick around.
Yeah, it's
I see a Steve and a Jen. Look at that.
Hello.
We almost have the whole tic-tac-toe board thing ready. Hollywood Squares, that's what it is.
I'm the only guy on this show old enough to remember Hollywood Squares, but it actually ran
Peter
on network
Marshall.
television.
Paul Lind.
Wow. How would you even know of that, James? You're a kid.
Oh, the YouTube compilations of him are amazing.
Yeah.
So, yeah, I don't, I worry about Nee a little bit. We hadn't heard from him. Of course, he's had a lot of, with the death of his sister, he's had a lot of things to tend to, and I would imagine he might not make it tonight.
Yeah.
And again, Rick probably will be out, and we might get Kim popping in from that EM conference in Colorado briefly. I was on a call earlier today, and we knew that she would not make that one. But Troy should be bopping on here from Tejas. Looks like the weather is cleared out of his neck of the world down there. So we'll get started here at the top of the hour. Nobody said any outrageous things yet. This has been a very disappointing pre-show. Man, I posted a picture of Cirrus and contrails and a sundog over Tennessee this afternoon. It got him going. I mean, it totally got him going.
You guys like my new posters behind me?
I do. I see Tracy, Minnesota up there.
Yeah, Tracy, and this is Wichita Falls right there. Then I got a couple of others. This is from the Gruzulis collection. And I've got the F scale over on this side, so I'm being surrounded by Gruzulis posters. It's awesome.
Nice set.
Yeah.
Let me see. Can you guys hear? Can you guys hear this? I totally forgot to change the audio settings.
Yes.
You picked a good one.
Okay. No, I was threatened within 5 minutes of that post that they send private messages that they have a chemtrail action team that will come after you. But one of them said I was a pathetic 80-year-old man. Yeah, baby. Yeah, baby. That's it. That's it. I'm in there with you. We control them right here. We control them. Now, this lady said I was a pathetic 80-year-old man that needs to go to the graveyard. F you. You're getting government money. You're a government shill. And they come in mass. There's just masses of men. Go look at that post in my Facebook page if you get a minute. You scroll down to and I had to delete the profane ones. The attacks come in private message, but you'll get an idea what I deal with. It says Gallatin, Tennessee this afternoon. Cirrus clouds, contrails, and a sundog. That's with no other comments. And they are like flies on poop. And welcome to our television viewers. Oh, we had a good time.
Right off the gate with a show title.
Yeah, there you go. Right out of the gate. So
it's interesting. I've actually gotten questions from some of our, more sane legislators about how to come up with answers to the many questions they get from constituents that are along those lines.
Woo.
So, which is tough.
Oh boy. Yeah, we better get this thing started. Yeah. Let's get the recorders going here. We'll get this show on the road. Track one. Welcome to our television viewers, by the way. Thank you for joining us. Here we go in 5, 4, 3, 2, 1.
You're listening to WeatherBrains. They're kind of a big deal.
WeatherBrains episode number 983. 983. Weekly show that is all about weather. 983 episodes. Wow. We'll be at 1,000 in the spring of 2025, and we turn 19 next year. How about that? So welcome. This is the show for weather geeks, dweebs, nerds, dorks, and weenies. And we're glad you're here. And let's go out to James Adelot in Tulsa. I guess the storms have cleared out of your area this evening, huh?
They have. Steve Piltz kept them well behaved as he kept instability from becoming a problem. They just kind of hit I-35 and went to a kind of a screeching halt in terms of QLCS tornado development. Not great news for Rick, who, when you wake up at 4:30 in the morning and he's already in chat.
Yeah, that's never a good thing. Our friends in Norman were dealing with what we deal with here very often, pre-dawn, after midnight, QLCS, spin-up tornadoes. Just, they're a booger to deal with in so many different ways. So Rick has been doing storm surveys. I think he probably has slept maybe 2 hours in the last 3 days, so he will probably not be able to make it tonight. But I do see joining us from Austin, Texas, Troy Kimmel. Troy, you're going to turn freezing cold. What are you going to see? A high of, 65 down there later this week?
Sometime in February, maybe. No, I don't think we're barely. I think we're going for 69 to 70, maybe on Wednesday. I'm not as impressed as I was a week ago with the coldness of this system, but nevertheless, it'll be a little bit cooler. But then you consider we're back in the mid 80s, James, in Austin by the time we get to next, I'd say Sunday and Monday across the area. So as far as I'm concerned, we really haven't broken the back of this heat just yet, this far south. And rainfall wise today, 1/4 of an inch, and we're in such a state of drought around here that was gone before you even noticed it even falling. So most of the dynamics or the best instability was off to the north, and rather to the east and northeast of us, back over parts of East Texas, northern Louisiana, and areas like that.
Probably had some trees with a big straw just slurping up what they could slurp up of that 1/4 inch.
I've noticed my yard, which I've let everything basically die out there, but we've had rain in the last couple of weeks, and it's greened up things a little bit, but largely there's a lot of soil visible out there around Austin. So I just can't you can't afford to put city water on the lawns, and that's what a lot of people, next door neighbors here, and a lot of people in Austin are doing. City of Austin actually, James, is paying people to get rid of St. Augustine. They'll pay you to pull it up out of your yard and zero-scape your yard, basically, here in Austin.
Wow.
Yep.
Wow. Goodness gracious. Well, let's go to the other end of the spectrum where Jen has got her snowblower, her Russian hat, her snow chains ready to go, Jen. So when does the winter storm begin?
So the S word enters the forecast Wednesday night and Thursday. As soon as I start seeing it, then I start using S words to run around the house, and I'm like, oh no, I got to get going with prepping the yard. And so I was out there today, 10 bags of leaves I had to get going to the curb, and mowed one more time, and just kind of, winterizing everything, because we go from 65 tomorrow to 35 on Thursday. And we are expecting a little bit of some light snow to try to come on in here. I don't think we're going to see a whole lot, but maybe a 1/2 inch up to an inch in the forecast. So, yeah, it's fun to see it the first time of the season, but then I'm done.
'Tis the season. 'Tis the season. I like it a lot. Yeah, we'll probably see a freeze for a lot of folks down here by the weekend. And there might be some snow in the mountains of East Tennessee, Western North Carolina with this. So, yeah, it's just a sign of the times. But let's get this show on the road here. Let's see, Bill. Yeah, Bill, we should mention that your football team is headed out to Oklahoma Saturday night to take on Oklahoma Sooners.
Go easy
Where's
on
our
us.
Norman? Our Norman associates are not here, but Alabama will take on Oklahoma in Norman Saturday night. A great night for football. Bill, how do you feel about the game?
I thought about changing my plans. I'm going to Milwaukee for a train show, and I thought about going out there and seeing Kim and Rick and James, and and having a big party because Alabama never plays well in Norman, so it's probably not going to turn out too well. But it'd be fun to be there, and that's one of my bucket list stadiums I've always wanted to go to for sure. So
I have never been to a football game at that stadium. I have been by
Yeah,
there
me
many,
neither.
many times, but I have never been in the stadium. So maybe one day, Bill. But let's bring in our guest. Let's get this show on the road.
Yeah, well, I'm excited tonight. James A's in charge of the guests tonight, so I'm gonna
Oh,
I'm gonna kick it over to him and let him introduce our guests, and I'm excited about the conversation. So, James, take it away.
All right, this is going to be a really great show. Steve Piltz, friend of the show, has been on several times, and he is the meteorologist in charge of the National Weather Service office here in Tulsa. And Dr. Jamie Jacob is an engineering professor at Oklahoma State University at the College of Engineering, Architecture, and Technology. I should know that because I'm a student in the College of Engineering, Architecture, and Technology. And you all have gotten hooked up with the coolest drone project, finally using UAVs to get some really neat granular data. We're going to get into that in just a bit. But Dr. Jamie Jacob, an engineer, we don't have engineers on this show too often. How in the world did you get involved with a weather project, engineering, UAVs, and how did you hook up with Steve Piltz? My apologies for that.
Yeah, that's the hard question to answer right there. But being a native Oklahoman, you kind of get bored into the weather bug. And I actually, did my undergraduate work at University of Oklahoma. And back in the 80s, we started on a project called a Tornado Chaser. And that was spearheaded by a couple of faculty there, Eric Rasmussen in the National
Mhm.
Severe Storms Lab, which I'm sure everyone is familiar with, and Professor Brian Argro, who was at OU at that time and is now at UC Boulder, and has really been kind of pioneering this concept ever since then. And of course, this idea goes back to the National Weather Service all the way back in the 1960s. Like, hey, can we take a small unmanned aircraft and fly it near severe weather to be able to get that really critical data. And I've been interested in it ever since. The technology wasn't ready for that concept back in the 80s, and it was just a matter of waiting for the technology to catch up to the science.
Where are you from in Oklahoma?
A Mustang originally.
Oh, very cool. Central Oklahoma again.
Yeah.
So, yeah, big history with tornadoes.
So I actually moved back to Oklahoma in 2006, really with the express intent of setting up a unmanned aircraft test program. And it was really just a matter of time before we connected with our folks down south, the School of Meteorology at University of Oklahoma, on a joint project funded by the National Science Foundation in 2015, and we've been working on this ever since.
Oh, that's fantastic. Can't wait to get into the nuts and bolts of that. And Steve, um, I know Ozzie Smith deprived you of an opportunity to play shortstop for the St. Louis Cardinals.
Where's that?
And so you went into weather. Tell us a little bit about your background.
Well, I'm from Illinois. I was born in Murfreesboro, so those folks that know the tri-state tornado history know my backgrounds there. Murfreesboro was also hit by an F4 tornado in 1957, about 4 years before I was born. So growing up, I could see the tension in the neighborhood every time it got windy and cloudy in March and April. And so weather was a fascination from the very beginning. And then eventually got into the National Weather Service. And my connection with Jamie goes back probably 12 or 13 Christmases ago when my wife Cheryl's son Daniel bought me about a $250 drone. For back then, that was good for me because that meant I didn't keep crashing the little remote control planes I had into trees and ponds. I could actually have something I could take my hands off the controls and it would sit there. So I like that. I posted a few things on Facebook about it because that's what you're supposed to do. And Jamie called one day and said, "Hey, we should talk." And so ever since then, he's been great at including me in activities and being a part of a lot of what they do. And so it's just been very fun to watch him work and watch all of his teams and the way he associates with everybody. He pulls everybody together into these conversations and tries to make everything work to where everybody gets to do something. And it's just a great environment he's created.
Well, Jamie, let's dive into it. What are you doing?
Well, we originally started with this idea back kind of the early, like Steve said, about a decade or so ago, and really starting to use the technology that advanced to the point where we could actually control these small, relatively inexpensive systems, to be able to get that weather data. And teamed up with a partner of mine at OU, Phil Chilson, who had been spearheading this idea when he was over in Europe and doing a lot of flights, primarily in Norway, get that atmospheric boundary layer. And really, the idea behind this is if we instrument the aircraft properly so that we get, the thermodynamic quantities, temperature, pressure, humidity, and then you can back out the wind properties in some way, either directly using some kind of wind sensor like an ultrasonic anemometer, hot wire, pitot probe, or indirectly, using things on the aircraft, then you can get the kinematic properties and get that wind as well. And really the focus is that atmospheric boundary layer, or the PBL, the stuff really close to the surface that provides that really critical weather information. Of course, ever since then, we've been trying to push the boundary higher and higher and higher to be able to, really replicate what we get with weather balloons. And so we've essentially staged this through a series of projects, starting off with a National Science Foundation project called CloudMap, which stood for Collaboration Leading Operational Unmanned Aircraft Development for Meteorology and Atmospheric Physics. And that was a team with meteorologists from University of Nebraska, Adam Houston being the lead there, and then some of our engineering faculty at University of Kentucky, Suzanne Smith and Sean Bailey. And that was really focused around, well, can we even do this? Can we get the data that we're looking for? Can we get these systems to really work? And this is really pushing the boundaries of what the FAA allows us to do about, flying the aircraft high enough where it starts to interfere with other aircraft that may be operating in the area, and then out of line of sight. And then since then, we've been basically scaling this up. We have a NASA project that we're just finishing up right now called WindMap. And that's essentially taking this more into urban areas. And we work really closely with partners at NCAR, National Center for Atmospheric Research, primarily James Pinto and his team on developing new models using graphic processing units so that we can get really fast, high resolution models very quickly, particularly around things like such as buildings. How do you fly these things in urban areas? And then more recently, Steve has been spearheading some projects with NOAA, with some of our other faculty. Now, how do we operationalize this? How do we get this stuff out there, take the data, and then feed it into the forecasting systems to determine, well, is it really going to improve the forecast or not? And that's where obviously Steve and his team comes in.
How much data do you need?
I'll let Steve answer that one.
Well, that's an interesting question, James, because a lot of the conversation when you get into talking about UAVs, you think about fitting them into models, and you need them every so many kilometers. You need to go this high, and the data has to be of this quality. But our office in Tulsa has really tried to get into mesoscale things and do digital mesoscale analysis where we can pull data into that analysis. And so I would say just even one or two data points could make a difference. You remember the Claremore tornado night? Obviously, James does. Where the model data began to mix all the moisture away from Tulsa. And so that left kind of a mixed bag of signals. Well, Jamie actually flew to 1,500 feet to the west of Stillwater at around 7 o'clock that evening, and it showed the moisture there. He just got to that moist layer, but that was enough to say, well, the moisture's there now. And that wasn't the be-all, end-all as to like one data point means everything. But, one data point near Tulsa that night could have completely changed the way we messaged from like, we think it's going to be bad, we need to prepare for bad, but we didn't know that certainly. But if we could see that moisture was still there in contrast to what the models were showing, we could have been even stronger with some of that messaging. And so I think even one or two data points could be really valuable in certain circumstances.
Yeah, I think going back to that question as well, a number of our team members have been running Aussies, basically taking data sets and determining, well, if, we have a drone in every mesonet site, or if we have a drone, every 50 kilometers, how does that improve the forecast? Does that give us enough data? What altitude do we need to go to? And we've shown that even 400 feet provide you improvements in your forecast. It may just be a couple of percent, but sometimes that's all you need to be able to determine whether your weather is going to be severe. Our real goal is, to be able to fly regularly and on demand. This 3D mesonet concept where we have essentially drones attached to mesonet towers or locations that fly regularly, but then also on demand. So, Steve could push a button and say, well, I really need a profile in this location to be able to refine my model. And, flying up to, 5,000 feet, if we can get up to, 500 millibars. I mean, that's the dream, obviously, but that's going to take us a while before we get there to be able to do that.
What are you looking at for dealing with the FAA? Because obviously they're not big fans of UAVs in the same airspace as manned aircraft. Um, how does that work? What did the FAA require you to do safety wise for this?
Yeah, it's a great question. And first I should say that, the FAA has come a long way since we first started doing this, about 15 years ago, where they're very much like, no, um, we don't really want you flying anything, anywhere, right, within the airspace, stick to your lane. And there's a famous saying that people talk about the FAA, they're not happy until you're not happy. But
True.
they've really changed their tune over the last half dozen years, because they realize how beneficial this can be. And from their standpoint, it's all about aviation safety. They want to keep the airspace safe. And if we can demonstrate that using these systems will determine, well, here's where you might have a microburst at, or shear or icing, and be able to help improve aircraft safety for manned aircraft, well, that's what they're all about, and very passionate about that. And obviously, it's a matter then of weighing the risk that you have with drones within the airspace and making sure that they are operating safely right now. So they've been working very diligently over the past several years to implement new rules, things such as detect and avoid systems that provide this Swiss cheese layered approach where like we're going to use these different systems to be able to determine that these UAVs aren't operating in the same airspace as manned aircraft. And we just did a great demonstration here in Tulsa as part of the WMO Global UAS Demonstration Program. So this is a campaign that started in February. Folks all across the globe taking data from UASN and ingesting it into various models. And we capped this off, thanks to James Pinto and his team by orchestrating a large flight test campaign around the Tulsa region. So both what was called mesoscales, which was led by Elizabeth Smith and her team at Seawero and partners at NSSL, the National Weather Center, and then one called microscales, which is really focused around the Tulsa downtown urban region, where we had dozens of participants from across the globe flying UAS up to 5,000 feet. Within, this congested airspace, and just showing that it is possible to do this safely, even when you have other aircraft operating. The FAA is still working on more plans, so they'll be rolling out what's called Part 108 pretty soon, which allows aircraft to fly beyond visual line of sight. And that's a real key piece. We want to be able to fly the drones. If we're going to get up to 20,000 feet, 30,000 feet, we're not going to see the UAVs anymore. So we have to be able to know what they're doing, even if we can't visually see them. So we have to have that regulatory structure in place before we can do that.
How does
And I heard
sense and
some cool
avoid?
statements, James, too. I was going to tell you, just I get to be on some calls with the FAA, and the statement was made a few months ago. We need to start treating the weather UAVs differently than other UAVs. Just that the weather UAVs can feedback positively into airspace management. And we got some feedback from some of the controllers where they said, as aircraft descend below 10,000 feet, they've got to come back. They got to throttle back below 250 knots, and there's aircraft spacing, and then there's turbulence avoidance. And the statement was made, if we could have UAS flights near that transition zone, we could better plan approaches into some of the bigger airports. And so there's, like Jamie said, there's there's increasing acceptance of the idea, and we've got some program ideas and project ideas kicking around with the FAA now that if you let us fly, say in Bixby, we're in that zone near the Bixby mesonet. We would be at that zone where aircraft is starting to descend below 10,000 feet. It's also in congested airspace around Riverside at Jinx, Oklahoma. But at the same time, maybe routine weather soundings from a UAV, could it positively impact the TAF for Riverside? So the FAA is open to these conversations now. So it seems more positive than you might first guess.
Is all of that avoidance burden on the UAV?
Well, I would say on the UAV operator, right? So,
Sure.
what we call the PIC or pilot in command, they're really responsible for knowing not only where the UAV is at, but also where surrounding aircraft are at that might be in the same airspace. And if you have a potential conflict, then it's a matter, of responsibility, due regard on the UAV operator to be able to, move that aircraft to a safe location, whether it's landing it or, flying it elsewhere. Right now, it's a mix of, basically using tracking telemetry on the UAV. So, by GPS, we know where the UAV is at. But simultaneously, using other systems such as radar, optical cameras to be able to track other aircraft in the area that may be non-cooperative. So, they're not broadcasting an ADS-B signal, for example, that you could pull off onto a tracking app.
And then the technology that Jamie mentions, he and I are in a project that's funded by NOAA that also includes Virginia Tech. Virginia Tech is recognized by the FAA for a lot of their work in safety, and they're designated as one of the entities that they designated some airspace there in the Mid-Atlantic for testing. And so they're looking at technology now that's going to be collaborated with Jamie's team, and hopefully a system kind of evolves out of that that would have an upward-looking radar that would track the aircraft coming into the flight zone or the flight column of the UAV. And that's where I mentioned to you a few months ago that we may need some practice intruder aircraft, and we'd back the laser defense system down on the UAV if you wanted to try that. So we appreciate that help.
Yeah, I'll
Yeah.
get back to you. So, I mean, it sounds like the safety issues are being addressed. When we look at, I guess, severe storm days are often fairly high dynamic days, a lot of wind, things like that. You don't probably have as many general aviation aircraft, but I imagine you have just as many commercial flights until convection's active. Um, how do you deal with, I guess, your ultralights and your non-radio aircraft? I know you talked about it just a little bit. I guess that really is all on sensors on the drone if you're not getting a radar blip or primary radar off of them.
Yeah, which is pretty rare. I mean, that you actually see those, but it does happen. I mean, there have been cases in particular where we've been doing some low altitude flights in Colorado near the Alamosa region, and the next thing you know, you have a crop duster that might be flying 50 feet off the deck that you didn't realize. Or the other flights we've done where we've been in MOAs, and an F-16 flies overhead 1,000 feet. And of course, you don't realize it's there until it's right on top of you. So again, that's where it becomes incumbent upon the operators to make sure that they're tracking the airspace and using other systems. So, we're still in the process of, developing and testing radars. Those tend to be pretty expensive, but other tracking systems such as optical and infrared cameras that use machine learning algorithms to differentiate, stuff in the background to say, well, that's a bird, so I'm not worried about that, but that's definitely an aircraft based upon that signal. And those have worked out pretty well. We have those in Tulsa right now that are operating continuously, ingesting that data so that way we can help train the system and use that as that safety measure when we're out flying.
Parameter wise, we'll shift gears a little bit. What's the most valuable data to have when you're meso analyzing a severe weather day?
Well, I think it's the standard information. I think we pull in data into our interactive system that lets us make our own calculations. Standard temperature, dew point, wind would be the main things. But then if if you put three systems in kind of a triangle out there, and making samples within a certain distance, you can begin to back out the calculations for vertical motions between the three UAV sites. And so that would be cool to add on to the basic information. And what I think we'll see if we get a chance to do this on a really active weather day is if we get the UAV up and we've got basically a Cape field that's out there, a measure of the instability that looks like what you think it would, and all of a sudden a bullseye shows up where Jamie has given us data, and now something is different at that site. We can say, hey, the models don't have a good handle on the instability, or the models don't have a good handle on the wind. And so even if it's just one data point, that's going to be a flag to the meso analyst to say, what you think and what the models are telling you is out there may not be out there. Look harder, be smarter about what you're thinking.
And that would be, I guess, take that data over an AWAS sensor any day, right, Troy?
Well, yeah, I mean, the AWAS sensor is only good as what's, 5 to 10 feet off the ground, except for the wind, and so when you get above that, and especially in that boundary layer, I assume that's pretty important. So, Jamie, one thing I have to tell you is I'm glad you brought up Adam Houston's name, because Adam came from Austin, and I knew him at McCallum High School, I believe, is where he went to high school, and he interned actually at the weather office here in Austin. I think a lot of Adam Houston and the work he's done up at Nebraska.
I didn't realize that. So
Yeah.
I learned something about him. So it's fantastic. I was just up there in Nebraska last month meeting with him and some of his colleagues in the computer science department. They're doing some really neat stuff in the world of aerial robotics. But yeah, Adam's got a really keen, meteorologist mind. He really kind of is able to understand the physics and what's really needed in terms of those measurements. And of course, he had a program last couple of years working with folks out of UC Boulder, called Taurus, really storm chasing. So in coupling not just the drone measurements using small fixed wing aircraft and some rotary wing aircraft from the ground, but also observations from manned aircraft above, being able to couple those and get, better data from both above and below.
Yeah. Well, I have to also give it to you and Steve. I know a lot about the office where Steve is, and I think data has been something that's always been very important in the Tulsa office. I can tell you past experiences of working with people up there, and they're great. But anyone between you two that you can get any noticeable change from the FAA, you win the prize from me, because I have talked to them before about things, and be damned if they're going to move 1 inch on certain things. But if we can do this, it's really great. And I commend you for the work that y'all are doing along with the FAA.
Well, again, I think going back to this, campaign that we just held in September, where, we had drones flying around Tulsa up to 5,000 feet.
Yeah.
And, within that Class C shelf around Tulsa International Airport. And demonstrating that, again, we can do that safely. Now that's still very much, under VFR conditions. What we really want to be able to do is fly those on those days where we can't see the drone or the aircraft around it, but it's going to take some time for us to be able to
sounds
get
like
there.
too, you've got a great group of people up in Tulsa at the Tracon or the Tower, and people like that are willing to work with this and to see how it could potentially, give them additional information in addition to the National Weather Service.
Yeah, I have to give
Weather
props definitely to both those offices. I mean, they've been really pushing the envelope. Because again, I think they understand what it means, for the future of weather forecasting and for the FAA in particular, aviation safety.
Yep.
How long do these flights last? Are the UAVs? I'm going to hit you with a bunch of questions. Are you talking quadcopters, hexcopters, fixed wing? Are they, I assume, battery?
All of the above. Almost everything that we use is electric, although we have some, longer range aircraft that actually, use your older gasoline propulsion motors. They can stay aloft a lot longer, due to the energy density that you get with hydrocarbon fuel over batteries. But everything from, systems that are about this size right here, this octocopter that you have, quadcopter is the same size, quadcopters no bigger than this, much smaller. And then fixed wing aircraft that, maybe a couple meters in span. All of the above. It really depends on what you want to measure and how you're measuring it. There are cases where we'll do just standard profiles, essentially mimicking what a weather balloon is supposed to do. I always like this because, weather balloons, we assume they go straight up, but of course they don't. They drift. And then you just take the data and, hope that it didn't drift too far and that, your variables didn't change too much over your lat long as you're ingesting them into the model. But, with the drones, we can essentially fly straight up and then come back down. And depending on how high you go, your flight's only going to be, anywhere from 5 to 10 minutes. The highest we've flown is 20,000 feet. And that's about, a 20 to 30-minute flight as it goes up and comes back down. But longer flights, if you're, using a fixed wing aircraft, particularly doing transects or orbits up and then orbits back down, you can fly for a couple of hours.
Got a question. I'm a professional drone pilot or licensed pilot myself. Are we talking, Jamie, about is this something that we build specially for this purpose? Or are we taking things like DJI and those products and developing it? Or is there another company that's out there that kind of specializes in what you and what you're looking for?
Yeah, there are a couple of companies now that focus on this. I mean, in theory, you can take those systems. Those don't necessarily work very well.
Okay.
So, we do a lot of custom in-house platforms as, do a number of our colleagues at different locations. But there are some companies out there. Meteodrone is one. So actually Meteomatics is the company and the Meteodrone is the product.
Wow.
And so that's a system that we flew to 20,000 feet. It's a standard hexcopter, configuration. Gives you your thermodynamic properties and your wind profile, and very much push button. You tell it how high to go, and it's going to come back down and spit out your SQT for you.
Is
So
it
very,
coming back, Jamie? Is that coming back at the same time it's in flight, or is that stored on board? I'm assuming it's coming back radio.
Yeah,
Yeah.
yeah. In this case, that the data is stored on board, and then you're getting it after the flight.
Oh, okay, okay,
But yeah, we do have some systems that are also streaming in real time.
okay.
Because ultimately, that's what we want to be able to do is stream that data as we're getting that. Some of this depends a lot on the processing. How you're getting that data off. How the wind is being determined. There's essentially two ways to do it. One is direct, using some kind of anemometer. The other is indirect, based upon the attitude of the aircraft.
Yeah.
And that requires essentially a lot of processing to be able to get that information off. And so you tend to have to do some calculations on those derived quantities before you're able to pull up.
And so that
profile.
wind stuff, Jamie, would be more or less like a Raywinson or Radioson, which of course has no anemometer or ultrasonic type. You're basically doing it via trajectory.
That's correct, right?
Okay.
But in this case, what we're doing is we're essentially keeping the aircraft in the same location. And then
Oh,
based
okay.
on the attitude of that aircraft, as
Okay.
it tilts over, you can basically correlate that tilt with the wind speed. And
Cool.
essentially run through a number of correlations to be able to get that accurately. Or you have a direct measuring sensor on board, such as an anemometer,
Right.
very similar to your ultrasonic anemometers that you have on your mesonet towers.
Yeah.
And you can have that directly integrated and pull that off. So a lot of that depends upon, what level of fidelity you want to get your wind measurements at, and if you want to measure turbulence as well. So if you're interested in turbulence quantities, you really need to have something that's going to give you, a much higher sampling rate than you can get typically with an IMU. But a lot of this stuff is, still being developed. And one of the studies that we have right now is essentially doing comparisons with radiosondes, to be able to see how well these systems compare with the radiosondes themselves.
I'm impressed. I love this, James. I think this is cool stuff.
Yeah, this is
Right.
amazing.
Yeah.
Troy, you mentioned companies too. It's interesting because normally when you think of the Weather Service or anything in the government, we're completely neutral, agnostic to any type of company. But back in April, the director of NOAA and the director of the Weather Service signed an agreement that allows me to work with a company called GreenSight. They're based out of Boston. They're just now starting to get into weather UAVs. And I say just now over the last couple of years, but they're still in a rapid development kind of phase. And so it's interesting that NOAA took enough of a notion to say we ought to work with some of these companies because they're getting close to doing something that with a little collaboration, maybe we accelerate the process. And so through this coming April, I get to work with them directly, and Jamie's been great to integrate activities, and so that was something I didn't expect. We always say weather service, no, we don't recommend anything. You know, you make your own minds up. But in this case, I've got permission to work with the company, which is kind of cool.
Yeah, and so they're developing a really neat concept where they essentially have, relatively small drones that are integrated into what they call a hive. So, it'll be able to launch, 10 to 20 drones out, and they'll essentially fly in a swarm to be able to get that data, over a distributed location, then fly back and recharge. Intermet, is also just rolling out a system. So more of a traditional weather company now, just starting to think about how they're able to develop these systems and getting in the hands of atmospheric scientists. It's still very much a exploratory phase right now of the industry, but it's very quickly this data is starting to be integrated, and particularly some of the countries in Europe are developing stations where they can start to do regular profiles and explore how they're integrating this data into their forecast, particularly those countries that suffer some from a severe winter weather.
And that's kind of the next logical step. Next question. There are incredible applications for winter storm forecasting with this data. Is that ever going to be possible to fly in icing or close to it?
I'm glad you asked. We haven't even talked about questions. You're already, seating these things up there. But, two of our researchers, Dr. Alyssa Avery and Gus Azevedo, are actually working on that very thing. And we've flown in icing before. And we're interested in this for a couple of reasons. One is the obvious, weather forecasting standpoint. At what layer, you're going to start to see icing happen, right? And you have to get that really right mix of conditions in terms of temperature and humidity for that to happen. But all the icing models that NASA and the FAA have developed over the years are for much larger aircraft. So everything we know about icing on aircraft is for large scale manned aircraft. For these smaller drones, those models break down. And so we're also studying this from the standpoint of how does ice form on drones? Because as we start to think about this, not just from a weather standpoint, but from UAVs being integrated in the airspace to do missions, and it could be a sensor platform like we're talking about, or it could be a delivery platform where it's just, delivering anything from emergency medical supplies to, burritos. And so if it's flying in that winter weather, you have to understand at what point is icing going to be hazardous for that aircraft? And we just don't understand that well at all right now.
How different is this data than, Steve, what you might get from ACARS, which the instrumented aircraft?
Well, I guess there's two things. One, the ACARS, isn't on our demand, so it's kind of random when we do see it, and the other is, it's on the slant range, either coming in or going out, where the UAV is going to be more vertical, and so there's different characteristics there. The ACARS data is great to have. There's just not enough of it. Like you all were talking about the storms last night, there's not a lot of ACARS data in the middle of the night. So when that atmosphere is destabilizing during the night, and the event from earlier in November, a couple of the forecasters in the office were pointing out the different model solutions in central and southern Oklahoma, and they weren't really lining up. And just one decent profile would have been great, but there was no ACARS data to compare against at that point. So the UAVs gives it that flexibility and let us look at things. And y'all were talking about the winter weather. Jamie and I have talked for a while to try to fly something when Oologah starts spitting out snowflakes. We have a lake that's oriented northeast southwest to the northeast of Tulsa that happens to align with one of the more common deep layer wind vectors from surface up to 8, 9, 10,000 feet during Arctic outbreaks that results in clouds and snowflakes coming into the Tulsa metro area. So Jamie and I have talked about that for a while. One of these days we want to fly a profile from the lake, from the top of the lake water there up, and just see what we have. That'd be fun.
Do you have battery issues like consumer batteries when it would be cold like that?
Yeah, we do. And actually, I'll share from one of my colleagues, Steve Pilson or Phil Chilson, and Tyler Bell. He had a number of his a team over in, I think it was I want to say it was Finland, but I might be wrong about that. I have to remember. It was a experiment called isobars, and they were out on a glacier in the winter, and they basically would pack all their batteries within their snowsuits next to their skin, so they could keep the batteries warm. Because they got too cold, then they just wouldn't operate properly. So
Hmm.
typically, once they start flowing, you have the charge from the battery. It keeps it warm when you're in flight. But if it gets too cold before it's actually basically operating, then you can have problems with that. So, but there are a number of issues related to operating these systems in really, really extreme temperatures.
That's amazing.
Hmm.
So, Steve, how can you just call Jamie up and say, I could really love a look at the profile over Pawnee today?
We exchange emails. He'll say, "Hey, if you see something coming up, let me know." And then it's just availability. I've texted him before, and where were you, Jamie? You were on a boat in the Pacific off South America doing things. And so his call sign at OSU is Rogue One because he's on the move, and it's hard to keep up with him. But yeah, Jamie will check in with me sometimes if I haven't checked in with him and said, "Hey, do you want to see a sounding later this evening?" And so he can fly pretty easily at a location west of Stillwater. And so he can fly next to a tower and get up to 1,500 feet. So we can see things like that. And that's the hope as we keep him stepping forward that we'll have a location like that somewhere closer to Tulsa that we can
Yeah,
also get a flight.
I really want to get to the point where, Steve doesn't have to call me, where he can just push a button, in his computer and it goes and gives him the data and he doesn't have to worry about what the UAV is doing. That's our goal, is we're not thinking about it anymore. It's just providing that data for him in real time. So we're not quite there yet. I have to get to the point where I'm the button pusher first. And so we're not there. So we still have to get out and take the systems out to the field, launch them somewhere. But we're getting pretty close, and we hope to have canned systems at some point next year, where now it gets to the point where we can do that on demand. Remotely monitor it, so we have cameras, and so we can see what's happening in the computer. We're getting the detect and avoid data, stream live as well, so that way we know what's happening around the vehicles, make sure that the airspace is safe. So we're getting closer, but hopefully, I would say by the end of the decade, we'll have some operational 3D mesonettes that will be, pipelining this data directly into National Weather Service models.
And I hear all the smart folks, Jamie and all the folks around him talking about all these things. And so, it was mentioned earlier, upward looking radars and things like that. You would integrate the detections from the radars back into the flight controller system. And so the even if a pilot wasn't directly controlling it, it would have a system with artificial intelligence, I'm sure, ramping up into the whole process too, to say you've got a potential flight collision at whatever, and it would tell the UAV to automatically hold at an altitude to let something pass, or in an emergency, it could execute a fall out of the sky maneuver. I think one of I think it's the media drone, isn't it, Jamie, that it'll fall to 250 feet and then deploy a parachute. That's its emergency out of the sky maneuver. So there's
Yeah,
there's a
yeah.
lot of cool stuff going on.
Yeah, it does have a parachute capability. And we have another company here in Oklahoma called Vigilant Aerospace Systems, and they've licensed basically a collision avoidance algorithm from NASA and have integrated into into their software package. So it will essentially track an aircraft and say, well, the aircraft is coming this way, and here's where my UAV is going, and it calculates what that trajectory is and say, well, there's a potential chance for collision. And then once you have that data, you can tell the UAV to essentially take a different path to be able to avoid that. And again, without really getting the pilot involved at all, it's all able to
Hmm.
do this completely autonomously.
So when are we going to get these things up to the tropopause?
Hmm.
35, 40,000 feet. Let's get real here. Come on now.
Okay, well, and one of the things that we're really focused on right now is we do a lot of high altitude ballooning. And Stephen mentioned Chile. We're down in Chile as part of a boundary layer study for eclipse, looking for gravity waves for our viewers not familiar with that, gravity waves are essentially very similar to waves that you have on the surface of the ocean, but great conveyor belts for transferring energy within the atmosphere. And so we're essentially using the eclipse as a way to, trigger gravity waves. It's kind of like dropping a pebble into the boundary layer, and seeing what happens with those ripples, after the eclipse essentially passes through a region. And so we've been doing a lot of balloon studies as part of that. And, some of these are want to be able to take the aircraft up on the balloon and be able to fly it down. And so that's one way to help solve that problem. Instead of going from the bottom up, we go from the top down. We're able to operate those aircraft within the tropopause. Now, it's not because we can't actually get the aircraft up there and fly them. Again, it's the issue safety. That's where all your commercial aircraft are operating at. And so, we really have to get to the point where our safety avoidance systems are working well enough that they can really track those aircraft operating within the commercial airlines and the airways that you have at those altitudes.
I guess
I
in some
think this
ways that's
stuff sounds.
easier. Oh, go ahead.
I was going to say, Phil, this is outstanding. So here's the next question for you guys. How long will we be launching radio signs, balloons? When does it stop? When's this going to take over operationally?
Well, first off, how long are we going to have helium? So, that'll be the first question. So, that's always a concern. Helium is a non-renewable resource. Once we've used it all, we've used it all.
I think most offices have switched over to hydrogen, haven't they?
Quite a few. I mean, we're still using helium for most of our balloon launches, but it's sometimes it's hit or miss on whether you can have that available, particularly on short notice or not. There'll always be a need for some of those balloon launches. We're actually transitioning a lot to solar balloons instead that are just using solar heating. But they're only operational during the day as well, so it's hard to do night operations around that. But I could foresee, within say 10 years, we really transitioned away from using radiosondes to using, basically drones that you can fly over and over again on command. Once we've solved the problem of, making sure that the airspace is safe and we can operate with non-cooperative aircraft, and we can kind of deconflict any type of potential for collisions, then we'll be able to do that regularly. So we know we can build aircraft that can fly to those altitude. The higher you get, the more expensive it becomes, but then you start to trade that off, and maybe most of your 3D Mesnet UAVs are lower altitude, 5, 10,000 feet, and then you have, one out of every 20 or one out of every 50, whatever that number that the meteorologist determine it needs to be, fly up to 50,000.
And we might see
This
too
is
where
outstanding.
the satellite data retrieval is considered pretty acceptable down to altitude X, whatever that is, and then the UAVs meet them at that. So we have some marriage between satellite data retrieval down to a certain level and UAV data retrieval up, and maybe that's where this ends up. Who knows?
I'm going to go for it. You had
I'm
a
going to take,
question.
I'm going to take flight real quick into this question, but kind of carrying off what James was talking about, I find this fascinating. And who would have thunk that we would be talking about this, and that this is, I mean, it's just amazing. So we always talk about what is the future of meteorology and what can students get involved in, and they have to almost be multifaceted in what they get involved with. So what are opportunities for high schoolers or college students if they wanted to get into something like this, especially if we think that this is going to be, a growing, entity? What are some things that they should really start looking at now, education wise, or, getting their drones pilot license or whatever it may be? What are some suggestions for that?
Yeah, this is one of the areas that we really focus on. One of the other hats that I wear is the director of the Oklahoma Aerospace Institute for Research and Education. And so really focused on, outreach in both research and, STEM education. And the first thing I always say is, well, programming, go learn how to program. Python, it's a great resource. And, programming skills translate to almost anything within STEM. But the great thing about this with aerial robotics is the controllers, the autopilots are becoming cheaper and cheaper and more capable every year. And it's a really easy and inexpensive hobby. to get into and do all kinds of cool things, particularly if you start to build up your own drones in your systems. You can, get a 3D printer, 3D print the body, start to integrate some of these inexpensive electronics, motors, and batteries. And then, take your, Arduino and, other sensors that you can get online, integrate those, and go out and start to take your own measurements.
And Jen, too, it's interesting. You mentioned the cross discipline things. Well, at the conference that Jamie hosted, the international conference that was in Tulsa, I met some I think they were freshmen, OSU students, and they're in the School of Engineering, but they're big weather weenies. And so a part of what they're doing is getting into the engineering because of their love of weather. So you're already starting to see that mix, that they still want to do engineering and not be a meteorologist, but meteorology is what's driving their interest. So it's great to talk to them, and they're going to come over and visit the office here in a few weeks and learn more about weather side too.
Yeah, it's really exciting talking to the students. They're just really passionate about it. This is one of the things I was, I think, being a native Oklahoman, you're always interested in the weather. And I didn't even really ever think about it as a career opportunity until, as an aerospace engineer, I got involved in some of these projects as an undergraduate student. But Steve was mentioning, this conference that we hosted back in September, ASARA, International Society for Atmospheric Research using remotely piloted aircraft, one of the worst, I think, society names possible. But great, team of researchers from all mixes. You have the roboticists, the engineers, the technologists, and of course the atmospheric scientists, the meteorologists, all coming together to think about this problem and figure out how to solve it in relatively inexpensive ways. But one of the teams that we actually had come out was a group called Otis, and I forget what the acronym stands for, but they're flying small quadcopters in tornadoes, not just around tornadoes, but actually getting the video. And we invited them out to say, "Hey, you're doing this. What we want you to do now is add some sensors on there because we really want that data coming off of this." And I know that they put a call out. One of their UAVs is still out there somewhere in Oklahoma with a data card on it that's got some cool videos. So if you come across one, go look them up on Twitter. You'll be able to. They'll be interested in getting that video back. But yeah, and that again was a group of interdisciplinary students. You had a team of, I think it was an engineer, computer scientist, and a meteorologist. They walk into a bar, and the next thing you know, they leave with a tornado chasing drone and get some great video out of it.
I want to say I know what the meteorologist, that is my little Nelson Tucker from Tornado Talk. He is the meteorologist who partnered up with his brother, who is a drone champion. And please look them up. It's Otis Project. It's at project_Otis on Twitter. And it's the observations of tornadoes by UAV systems.
There you go. Thank you.
Yeah,
So,
I had to look it up real quick. But
Yeah.
it's fascinating what he's done with that. And they just spearheaded it this year. And they're doing a lot of growth with that. Maybe we can talk to them at some point, guys, and get them on the show to talk about that aspect of it. But yeah, I'm so glad that you said that, Jamie, because it's a great project.
Yeah, and they had some fantastic video. They teamed up with the seasoned storm chaser, so they weren't just, going out and doing this, unsafely. But one of the things I'm really passionate about is getting this in the hands of storm chasers, right? Because we all know on this, call here that storm chasing, is really important to be able to get that data and get eyes on the severe weather. But we all go back to, Tim Samaras and the Reno event. Having that ability to have a standoff where you can get close enough to a storm where you can now launch a drone or UAV to be able to get eyes on it, and at the same time be able to get some really critical weather data as you're getting close to it. That's already happening now. We mentioned Adam Houston and Brian Argro. Their teams are already doing this type of work, but this is eventually going to be a standard tool for every storm chaser.
Steve, I'll ask you. This is going to be incredible data. We've talked. You mentioned the Claremore night. We've talked big tornado type setups and getting better data. How is this going to help us on a day like today, this morning in Oklahoma, or air mass thunderstorms in the summer, are we ever going to see it get down to that point where it's going to give you a tangible benefit?
Well, if the 3D mesonet vision happens, and it will, like Jamie said, by the end of the decade, that's probably something that's within our reach. Imagine the Oklahoma mesonet with each side having a UAV that could be launched to 5,000 feet every hour, and it goes up, it flies, it brings its data back down, it goes into some kind of hive type of thing where it's protected, it's charged, and it's relaunched from there. Imagine that kind of spatial data to know that the cap is this deep here, but it's different than that over here, and the instability is there, and the moisture is a little deeper over here than there, and that I think that's going to be what we're going to find is a lot of the subtleties are going to be important. The things that we see as just not forecastable right now, they're going to become more forecastable because we're going to see the things that we only kind of scratch the surface at. Even when we look at model data, we're still kind of scratching the surface because models aren't perfect. And so I think the 3D mesonet is a big deal. Then you get with what Jamie's saying. We have chasers who's actually then targeting locations and doing things. I think all that begins to layer on top of each other and become pretty important because I think there will be a point when all this begins to happen that things we kind of thought we knew about severe weather are going to get refined to a point where we say, okay, that's what's going on, and there's going to be a jump forward.
Yeah, and I can easily foresee, down the road, within the next, 5 or 6 years, that we'll essentially have a suite of different tools. It'll be these regular profilers that again might be stationed, mesonet, and we might have it increased density around regions where, we might want better data, whether it's in our urban locations or whether it's just, regions where, we tend to get some kind of natural effect, near lakes or other bodies of water or mountains. But then we also have systems that are be a little more capable, probably fixed wing systems, still probably electric, still autonomous, slightly larger, probably with the ability to take off vertically and land vertically. But now they could do targeted observation. So, they can leave from an airport. You'll be able to travel to a dry line or, a severe storm or an area of increased convection. Be able to do targeted observations using the data, not necessarily being controlled or commanded by someone on the ground, but now taking that in data and using, their machine learning algorithms or, we'll call them AI capabilities on board that are then telling them, well, this is the area of interest, based upon what I see, I should fly over here and get this data or, this altitude and, determine if I need to do an orbit around this region to be able to increase what I'm measuring. And then also do radiosonde drops, be able to do drop sondes to be able to get data and have that radio back to the aircraft, which then is radio back down to the ground station and have that data ingested in real time into the continuously running models that we'll have. We're not too far off with the increase in processing power that we're getting. That we're going to see this phase where our models are essentially continuously running, continuously ingesting new data to give us basically a continually changing and more refined forecast as we're moving forward.
Somebody's muted.
Oh, yep, that's me. We're sorting out a 9 o'clock newscast too. Um, so technologically, what's the next? What do you? I mean, you've seen this incredible technological capability grow. What's the next step you really are craving with this technology?
Man, for me, it's being able to fly in the clouds. And, we've been working really closely with our friends down in the Choctaw Nation. They run an FAA test site. Originally started off with the IPP program. It's now in the Beyond test site. And they have some great BVLOS capabilities. But the FAA is always just balking at, well, we don't want you to fly in the clouds yet. Even though like, well, we've got radar, we can see all the aircraft around us. We can see everything, using the radar systems. Like, yeah, but you can't see the air, can't see the drone. So we're just not comfortable with that yet. So,
Yeah.
but being able to fly into the clouds and get that cloud data, I'm really, really excited about that, just so we can start to better understand the cloud physics. Some of our colleagues, Heist DeBoer, did some flights. They had to go to the Caribbean for it. I felt really bad for them flying off the coast of Barbados to be able to do these cloud studies. But flying into clouds and really understanding what's happening, within those clouds. He and his Heiss and one of his colleagues, Greg Roberts from Meteo France, working on these capabilities and being able to do that here in the U.S. And again, getting that data is going to be really pivotal for what's happening within the cloud to be able to feed that back into the forecasting system.
Steve, that's a lot of information for an operational forecaster, and we're just adding more and more and more. Uh, how does it fit in? Are we machine languaging, AI? I mean, we're just throwing more data right into the operational forecaster's brain.
Yeah, and when you think about that, as the modeling improves and you look out 2 or 3 or 4 or 5 days, that continues to improve. And there's the conversation of, well, maybe there's not a role for a meteorologist, but it could be that you will be more of a meteorologist than you ever imagined if you begin to try to get your mind around the mesoscale things and the short-term things that are going on. That's still a fairly unexplored area when you start getting down to these levels, when you're talking about data every mesonet site, something like that, and even finer in certain circumstances. So I think there just may be an evolution to where AI is getting pretty good, especially at days 3, 4, 5, 6. Maybe that's the evolution that we see in meteorology, and the meteorologists are going to let some of that go as they focus in to really try to tell whoever's got soccer practice at 2 o'clock, it's going to start raining at 2:05, kind of thing, because maybe those are the things that we see evolve as we start pulling in this higher resolution data. So meteorology is definitely going to evolve. And we're just going to, and we always say we're drinking out of a fire hose anyway. We're just going to have to figure this out and be a little smart about it. But I think that's the evolution.
Well, one thing I always caution folks on, right? Garbage in, garbage out. So, you really have to be able to, look at the data coming in and,
Mm-hmm.
using your we'll call it atmospheric science intuition, be able to determine, how good is that actual data? That you're getting, is there a sensor off
Mm-hmm.
there? I mean, we see that in the mesonet all the time where we,
Yep.
see a slightly off reading. And that can have a big impact in your forecast. And unless you're going out and continuously, doing calibration validation on those sensors, because every sensor drifts at some point or breaks at some point in time. Making sure that you're able to make sense out of that and determine when you should ignore the data, versus paying attention to it.
And AI is going to really need that scrutiny, because it's going to train all these data on all these data, and it's going to believe that's the fact. And if that sensor's drifting and you have a bias, and we all know, we can all pick out observations in our backyard that dew point's been 3 or 4 degrees off for the past X number of weeks and those kinds of things. That's all going to have to be taken care of at some point. So there's going to be humans going through some of that, at least initially, before the AI gets smart enough to correct itself. I don't know where the limit is on that, but I think, yeah, Jamie hits that, where that's a role for the meteorologist. And when we do our digital mesoscale analysis, that's one of the things we're doing. We're able to see that station that has the dew point bias, and we can correct that, and then we can make these things. That's something we're kind of trying to explore now, and I think that's where some of this is going to have to go.
One of we haven't really touched upon this yet, but one of the other areas where this can be really impactful is fire weather. As we see, wildfires, rangeland fires just become more and more prevalent, and that's going to be an issue that we have to deal with. As the climate continues to change, how do we, pull data like that in to be able to help improve the forecast predictions? And this again is where one area where aerial surveys are particularly useful, because now they can survey the terrain. They can look for fire load measurements, essentially using their cameras, EO, IR sensors to be able to pull that information off. So you can look at both quantity and quality of the fuel that you have and say, okay, this is a dry day down here. There's a lot of dry fuel in this area, and the winds are starting to change. And here's our humidity now has really dropped. And then you can take that data and ingest that into fire models. And those again are going to be things that help save lives, particularly when you have your hot shots. Trying to help stop the fires and save property and lives. And plenty of firefighters have lost their lives, just because they've been in the wrong place at the wrong time, and the fire did something that was unpredicted.
This is good stuff. I've said all along for years and years. Here we are launching two balloons a day from one spot in most states, one. And what in the world can change in the atmosphere in 12 hours? And I know on active days you might launch a special 18Z balloon or something, but are you kidding me? What year is this? 2024. And so, what this discussion, it gives us all hope here. This is outstanding. And goodness gracious, my biggest challenge, it's random air mass convection in the summer. Every day, I know we're going to have storms at 3, 4, 5 o'clock in the afternoon, but I have no idea at 7 a.m. where the storms will develop. And accordingly, the forecast says hot and humid with a chance of scattered afternoon and evening thunderstorms. The probability of precipitation is 30%. What good does that do if you've got a baseball game with your child at 5 o'clock at West Homewood Park? People need to know, is it going to rain there or not? I have no idea. And to me, this opens the door, fellas, maybe for some hope that we can deal with random air mass convection with this better data in the future.
Yes.
I hope so. I hope so. I think hopefully that's what you see, is that this site, the moisture is deeper over west part of Alabama this afternoon, and over the east part you'll see it the next day. Hey, look, now the deeper moisture is over there, and we'll learn those things. We may start to have the data to allow the meteorologists to see that and say with some confidence. And so instead of 30% of the entire area, maybe 60% of this area over here is going to have storms, and that's a better forecast.
Yeah, I know
And
what
the
my
other,
wife really wants is to understand why Stillwater always have a split. When it's really dry, we have that rain moving towards us, and it just splits and moves around. It's like, where's the water for our garden? And if, someone can explain that someday, and maybe, the UAVs will be able to help with that forecast.
And the other biggest challenge we have here, it's winter storms. And low latitude winter storms are hard. And if you say they're not, you are lying through your teeth. You have not worked a shift trying to deal with precipitation type. You can go from one side of the city where they've got a cold rain. One side of the city, they've got snow falling and it could be heavy. And then down to the south, they've got ice. They've got rain falling and it's 29 degrees with icing conditions. And trying to figure that out, it's challenging. And the models sometimes are not that much help. And obviously, the better data into these things. And so let's talk about timing. So you talked about this magical button you hit where the thing goes up. How far away are we? How many years?
Oh, I thought Steve was
You're
going
the
to answer that
expert.
one for me. I'm going to say, we can technologically, we could do that now, right? So it's not a matter of whether we can do that from a technical standpoint. It's from getting the approvals and making sure that we're doing that safely. So well within 5 years, I think we'll be able to do that. The question will be how many, who's owning those systems,
Now, and how is
who's
it
paying for
rolled
them?
out?
What?
How is it rolled out? Who gets
Yeah,
it? How is it rolled out?
exactly. Yeah, and we don't know. Those are questions that we're discussing now, right? Most likely the National Weather Service is going to go through a data buy process where someone else is owning the systems. Maybe they're privately owned and they're selling the data. Maybe they're owned by the state or municipalities or some combination thereof. And then I think it's just going to be a matter of how many of these systems do you have? Still an open question in terms of how many do we need until we get to the point where like, yeah, this is good enough, right? We have the data that we need that Steve's going to be happy with for his forecast.
Well, hopefully, maybe we could get a few of these at sites where we've had to discontinue upper air soundings. like Tallahassee, I guess, and other places where they haven't had a choice. But as you pointed out, Jamie, earlier, have the to have the hydrogen as an alternative, and not able to do it. We're losing those sites.
Yeah. And it all comes down to cost, right? If we
Yeah.
can make these systems, cheap enough, and what's really driving this, I always like to kind of, show it's always the cell phone, right? It's the technology that goes in here that really makes these things very inexpensive. If you get to the point, where you can ensure that these systems are, small enough, inexpensive enough and frangible so they can't cause any harm to larger aircraft, then it almost becomes a moot point in that case. It's like, okay, we can operate these systems safely.
Yep.
And I think
So
Jamie hit it too.
Steve,
Go ahead, James. I was just going to say, Jamie,
go ahead, Steve.
hit it that the Weather Service will probably not fly their own drones. So the entrepreneurs that are listening that want to start their own company up in 5 to 10 years, or it may be just like the mesonettes now, where it's done by the state, it's done by the community. But there'll probably be some companies that'll jump in there and say, hey, we'll do the Alabama UAS weather system. And if they get the contract for it, maybe they do it. And then the Weather Service buys the data that way. So I don't think we're going to fly ourselves. I think it's going to be some other entities doing that.
So you talked about real-time model output, just constantly updating. You don't have to worry about an 06Z run, a 12Z run, the hurry. It's constantly updating. How far away are we from this? When's that going to kick in? That makes me happy. Just sitting here at a screen, it's constantly updating. You're not waiting on the next hour run. When is this going to happen?
I think Steve said maybe next
forecast
week.
orders on that, doesn't it? It seems, Jamie, I mean, they're doing about every 30 minutes now when they run it, but that's not still continuous. So yeah, I don't know when the computer power is hard. It just is. But I think every 30-minute runs for the NSSL one on forecast system, which is transitioning to the Weather Service now. So it'll be more under Weather Service control as we go forward. That's gonna gradually happen. So 30-minute runs are still cool, but you've seen those data where they're over domains or not over the whole country. So the domain may not be over you the day that you want it. So Jamie's he's the guru on all that. When's that gonna happen, Jamie?
Those are our in-car and other partners, within the National Weather Center. But doing some amazing stuff, right? And it's all those NVIDIA chips that everyone's buying, and the cool stuff that you can do with the graphic processing units. So again, well, down the road, right? Our kids will be running these high resolution models on their phones. And so I don't even need to pull it off anywhere else, right? I've got it all in the palm of my hand.
Mm-hmm.
So what's going to come first, that or phased array radar?
I'd say phased array radar, but hey, that's where I'll put my money at.
Of course, I'll be at the graveyard when all this happens anyway. I'm just we have a lot of younger people that are listening to this, but it's obviously there's going to be some opportunities, fellas, for folks that might want to get into this business. Since the Weather Service won't be flying. And I think there's a great window here, don't you, for some entrepreneurs?
Yeah, that's why you see some of these companies now getting involved, right? And say, hey, I can develop these systems and do something new, and really start to compete with, I would say, more traditional players within the field. And of course, we start to see this now. I'm sure we'll see more of this at this year's AMS with companies, rolling out these ideas. And it's the technology is changing so quickly now that again, like Steve said, anticipate by the end of the decade, we're really going to start to see this regularly integrated into the forecasting enterprise and daily observations. And it all goes back, James, right, to this crazy idea that in typical state you've got one location where you're launching a balloon, and you think, well, that data is enough. And again, that may be all you need for your high altitude, right? And the rest of it can be low altitude. And that may be satisfactory.
Exciting times ahead. Fellas, we have to take a break here in just a second. But Steve, real quick, I just wanted to ask what's happening at the Weather Service in Tulsa. How's things going? Real quick before we take a break. What's happening at the office? Tell us something good.
Well, we skipped most of the severe weather today, so that was good. So we've got some down days. James likes that. Colder weather coming. I keep seeing winter weather, not too far out in early December, but it keeps moving back in the models. James just loves that. So, but things are good in the Weather Service in Tulsa. Everything's moving along like it should, and it's just great to be a part of some of these innovative projects because I think that's where the future is.
And it seems like, James A., you have a good relationship. The media has a good relationship with the Weather Service there.
Oh, absolutely. I mean, there's no way we could do our job without them, and hopefully there's at least some mutual benefit there. During severe weather, the chat is very active both ways, and it's man, I wouldn't trade these guys for anyone, guys and
Have,
girls.
have, have you done an IWT session lately, an in-person session?
Not in person. We had one, and I think the plans are still on it. They were going to try to do it. We're going to try to get it squared away this fall, but I think it's been pushed back to probably after the holidays now. So that'll be our first chance to get back together again in person.
And they actually had one here.
Oh, go ahead.
I was going to say that I couldn't attend, but it's good to see after COVID they're starting up again, which is good.
Yeah, COVID, and it's amazing how profound that effect was and the lag of getting some things restarted again. But that's something we do. And one thing that's been great, we have a local AMS and now NWA kind of merge chapter that's going on, and so a lot of those meetings are held at the Weather Service office, and so we have these informal get-togethers every month or two that are Weather Service, local media folks, and some emergency managers as well that happen under that umbrella. So those interactions have picked back up and they're doing well. So those are always great meetings.
Awesome. Well, let's take a quick break, and I did not see a report from Tony this week, but we're going to hear from Jen this week in tornado history. We're going to come back and we will do a quick little weather roundup. We will do picks of the week and much more as WeatherBrains rolls along.
This week in tornado history, one of the largest fall tornado outbreaks in the U.S. occurred from November 21st through the 23rd in 1992. For the NOAA National Disaster Survey report of the event, a total of 94 tornado tracks were identified during this widespread episode, which was unusually intense for November. There was a total of 6 tornadoes rated F4 and 15 rated F3. Over 600 people were injured, and there were 26 fatalities. 15 of the 26 deaths were in the state of Mississippi, and 12 of those were caused by one tornado that crossed through parts of 7 counties. For the National Weather Service storm data entry, the tornado reached maximum strength of F4 in the town of Brandon. It was here that a mobile home park was hit, destroying 30 trailers. 4 people were killed. A large, well-built brick house in the East Haven subdivision was demolished. 4 people were killed, 3 of which were Cub Scouts at a sleepover. Along other parts of the track, there was tremendous damage. Another mobile home park was hit on the south side of Florence, and over 100 homes were damaged or destroyed in Choctaw County. In the midst of such tragedy, there were stories of hope, survival, and miracles. A 6-day-old baby girl, Celisa Vance, survived after her family's mobile home was tossed by the tornado in Florence. Parents Curtis and Adrian were in the home as well and suffered injuries. They found the infant in underbrush next to a tree. Learn more about this devastating event and other tornadoes from the outbreak on our website at tornadotalk.com.
All right, Jen, let's do a quick weather roundup. I know we talked about it at the top of the show, but anybody have any thoughts on the hurricane season? Since I think we can just about, and Troy, you're our tropical correspondent. You're the lowest latitude guy here. I just think
guy here.
I think we can stick a fork in it. It's done. What do you say?
Well, I think probably is, but one thing that still amazes me is we're at the point of the season where we are and how warm those Gulf and Atlantic waters still are. There is still a tremendous amount of latent heat out there. But I think that, as you can tell with whatever this silly thing is that's over the Yucatan right now that's been out there, it's going to be turned very quickly, whatever's left, a frontal low, and emerge along this secondary front due in our area, I guess, by tomorrow evening. So I think it's about over with, but you never say never, believe me, around here, at least till the last day, the 30th day of November.
And you never know. We've had them in December before, but it just seems like the upper air pattern is kind of favoring things, calming down a little bit. And, there was a little ruckus, fellas. I don't know if we should bring this up on the show, but hey, let's bring it up on the show. So AccuWeather posted their own forecast track and cone, and they had a very meaningful hurricane coming into South Florida, uh, basically today or tomorrow. And as it turned out, there was no hurricane. Um, I didn't. When did they start issuing their own forecast tracks and cones? Is this something new, Troy? I don't.
I don't know. I thought we left that expertise to the National Hurricane Center. That's the way I've always sort of looked at it, and I trust those people there. But keep in mind that AccuWeather wasn't the only thing. I mean, good Lord, look at the social media in the last week and all the trash that's been out there. And again, just remember 60% of everything on the internet is crap. That's my saying. And so just always remember that. Less any National Weather Service sites or things from the National Hurricane Center or the Weather Prediction Center. Folks, use caution. Use at your own risk.
And I did see that one of the meteorologists involved in that apologized publicly.
Yep.
And I'm hoping that you just learn from your mistake, and maybe they'll stop doing that. I'm not. It's like issuing your own tornado warnings. If James Adelot's got a tornado warning going here, and you got Steve at the Weather Service with no tornado warning, or vice versa, it's chaotic.
If James goes about doing that, God does not create enough insurance to cover James for the liability associated with issuing their own tornado warning. And that's one thing media people better remember. I think we've done that pretty well in this country. There is not enough insurance on the face of the earth that if you cause a problem by issuing your own warning, where you create a panic, you begin to create confusion in the emergency management office. You start to do things like that, there's not enough insurance in the world that'll cover you.
While we're chasing, before we do picks of the week, but while we're chasing rabbits, let me just chase another one. I saw some really, really, really bizarre videos and statements from professional meteorologists after the election, and I understand better than anybody here that this nation is polarized. The nation is charged and ready to fight, and they want to fight, and they want to hurt somebody if their candidate was criticized or whatever. And again, as a disclaimer, I don't care. I vote and that's it. I don't think about politics. I don't. But I've seen some professional meteorologists say that if you didn't vote for my candidate, F you. And if there's a tornado coming through, I'm not going to help you and I'm not going to take care of you. That's a really, really, really bad message. And I think some of these, from some of the videos I can tell, I do believe that some of them have some type of psychiatric disorder, where they went from these F-bombs and F you, and I'm not going to help you, to they started weeping. And I don't think they were doing it for views or clicks. I just think they just needed to get on there and say that stuff. But so if you're telling people that we're not going to help you if you voted Democrat or Republican or whatever, that's a problem. And I hope, goodness gracious, I hope that the weather enterprise is not headed toward journalism. So journalism, it's all, partisan. If you're
journalism's dead. I hate to say
if you're a conservative, you go watch Fox. If you're a liberal, you go watch CNN or MSNBC. You want to hear what you want to hear. And if the weather enterprise gets into this, where I'm going to follow this guy because he's a left winger, I'm going to follow. That's problematic. And
that goes back, James. That goes back to the basic premise or thought of having critical thought and being able to come up with something reasonable. There is so much lack of critical thought in this country. It amazes me. It scares me.
And I just anyway. That's as far as Gump would say. That's all I got to say about that. But I just see a very troubling trend.
Yep.
And of course, I don't get into it. I don't want to. I don't have time for it. I am busy. I mean, you look up busy in the dictionary, it's got my face in there. I sleep 2 or 3 hours a night. I work from 4 a.m. to midnight every day. And I love what I do. There's no complaints here, but I don't have time to deal with politics. But I just put out, after seeing one of these videos where this guy was saying, F you, F you, F you. If you voted for this guy, I hope you go straight to whatever. And you're not going to get any help from the Weather Service. You're not going to get any help from the Storm Prediction Center, blah, 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 blah. And by the way, some of these were these folks were not just rogue YouTubers. Some of these folks work for the Weather Service. And after I've seen enough of that. And I just put out a little statement that said, listen, if you voted for Democrat, Republican, it doesn't matter to me. You're going to get the same service from the weather enterprise, no matter who you voted for. Have that level of comfort. And of course, what
Absolutely.
happened? I was immediately attacked. And you said, I'm thinking, goodness gracious.
James Spann's been canceled.
Oh yeah. Oh, goodness. After the chemtrail thing today, they all come after me. Left wingers come after me. Right wingers come after me. I guess I'm doing it right, but
you are.
I guess Steve, you're not going to look at some county map and say, ooh, they voted, Republican. We're not going to issue a tornado warning, or they voted Democrat. We're not. You don't do that, do you?
No, I mean, even if it's in a rural area and you're like, well, it's away from town, maybe we can, look at this storm a little while longer. You still know that there's people there. You don't know who's camping somewhere. You just put out warnings the best you can with the best data you have, and everything else is a non-starter.
I've never known a weather service person that would ever do that. Anyone that would work for NOAA, the National Weather Service. I can't imagine that. And just remember, folks, another thing too, you go on social media, it's going to be there for how long? Forever.
Yeah.
Ever, forever and ever. And it'll come back to haunt you, and it could take your job away. So you want to be careful with that.
And of course, some of these folks, maybe they had been drinking or something, but they deleted it. But like you say, there's screen grabs all over the place. It's never, ever going to go away. But I just want and again, people that are listening to this show, the Weather Enterprise is going to take care of you no matter who you voted for.
Absolutely.
And politics should not enter any of this when it comes to what we do, which is mitigating loss of life during high impact weather events. It doesn't cross my mind. It never has, and it never will. And for those in the weather enterprise that can't stop, that just can't stop, the guy that was saying, F you, F you, F you, we're not going to take care of you. Just quit and go do politics. If your passion is politics, then you need to go run for office or go work for one of these candidates. That's great. That's marvelous. But you don't need to be in the weather enterprise doing that. And it was very disappointing to see a lot of folks with some really, really nasty, harsh rhetoric, not only over the situation, but directed at specific people groups because of who they voted for, and basically saying, we're not going to take care of you. And I don't believe that Ken Graham would be cool with that, or anybody within the Weather Service would be cool with that. So,
well, the weather enterprise should be ashamed of it. That it even would come up as being something you'd even think about. I would never have thought of anything, James. I'm like you. I wouldn't have ever thought about that. And the fact that someone does, you ought to be ashamed.
Well, and we've talked about this before, and but I think it is worth repeating. Troy and I brought this up when we had our college show. Stop before you post. Emotionally driven posts. It's emotionally driven. I know exactly what you're talking about, James. I watched the video, and it's awful to see, and it's a hateful rhetoric, and it's emotionally driven. And please stop before you post, because you cannot take that back. Someone is going to screen grab that, and they're going to out you, and they're going to see that you are part of the weather enterprise or whatever. And then it's just going to go viral. And, people are having some remorse for posting things, but it's already, the cat's out of the bag. Yeah.
Well, so please stop. Jen, please. And Jen and I talked about, especially students out there that are at colleges, universities, high schools, because that will follow you the rest of your life, and it will eliminate you from jobs. Don't be surprised.
Yeah. Yep.
Again, we all vote and we all have opinions, and it's a very highly charged time. I understand that. And fine. If you could put a campaign sign in your yard, fine. If you support a candidate, that's great.
Perfect. Yeah.
But turning it into this rage against the people that you serve, there's something really, really wrong with that. Some of my dear friends voted left, some voted right. It's great. I still get hung up in this stuff. So, all right, we got to move along before we get in trouble here. So let's do picks of the week. So Jamie and Steve, we'll go to you at the end here, but everybody's going to have a chance to share something that's really cool. This can be a website, a data source, computer code, book, hardware, software, instruments, something. And again, all this will be put up on the website, weatherbrains.com. So I'll start. I stumbled onto this site, and it looks like it's coming out of the University of Michigan, where if you go to this site, it will show you tornadoes in the United States on this date in history on a map. From 1950 to the current time. And this is fascinating. I like weather history. I like to study history. And it's just kind of a cool visual presentation of looking at what's happened in the past as opposed to just a written narrative here. So again, we'll put the link up to that on weatherbrains.com.
James,
so
I got a question for you.
Jen,
let me ask you a question
yes.
about that site real quick. I looked at that site you sent us and we got to see it ahead of time. There's no way to put in another date other than today's, right? It's just a history for today's date, right?
I could not figure
as
that
best
out.
I can.
Yeah.
Yeah. That's
It's
the one thing I was
It's just for today's date.
Okay, just for today's date. Okay.
Yeah,
But
and
it's
it would
really
be nice
good.
if you could pick a date, but they list, they have a text list and they have a graphic here, and of course you can select these and learn more about them. But I just, to me, maybe I'm just a nerd or a goofus or something, but I like to see what happened on this date in history. I love on this date in history. I love those. Bill Murray wrote a really good one about today. We had tornadoes in Alabama on this date in 1957. We had one person killed in the Birmingham metro. We had 4 people killed in Albertville. Fascinating case study. And it was the second of a 2-day outbreak. It started the day before. We had 3 people killed in Jasper, Alabama. And I love this stuff. And this was in 57. And you can learn from what's happened in the past. So anyway, we'll put a link up on weatherbrains.com. All right, Jen, go. What you got?
So it's a combo pick of the week email. This came in from Brian Fowler, who had a couple of suggestions for picks of the week. And I'm going to go with his Ryan Hall pick. And I actually clicked on the link. Ryan's got a new 24/7 live weather stream. And it's in its infancy here, but it is actually very fascinating and very innovative. And it's a secondary channel, and it blends the weather radars. It was going through weather alert, special weather statements, and then it would go over and highlight severe thunderstorm warnings, updates for the National Hurricane Center, SPC, has a music soundtrack, and it's essentially a 24/7 live weather stream. And what's also interesting, he's got a little AI, they calls it the y'all bot, that is narrating and explaining watches and warnings. And so, when we talk about what does the future hold, I think this, we keep looking at this with the YouTube streams and the 24/7 things, and it's a very fascinating thing. I'll be interested to continue to watch how this grows from him. So it's the YouTube link of that soft launch of that.
Okay. And again, we have to learn. Listen, what's going to evolve here, it's going to be the best of the YouTubers and their ability to reach people, the best of the old school broadcasters. And something really good is going to come out of this. I'm hoping that younger people that want to do this for a living are not discouraged by the death of linear television and what I've done for all these years, but they see great potential for the future that will be this amazing combination of new and old. And again, we just need to learn from each other instead of being hostile toward each other, in my opinion. So James Adelot, we got to get him because soon he's going to be doing the 9 o'clock news, live, local, late breaking, the Weather Authority.
Absolutely. Hey, and mine is this November in Tulsa. Not only is it the wettest November in Tulsa weather records by more than 4 inches, it's also now the 6th wettest overall month in Tulsa weather records. And out of that top 6, as you would expect, 3 of those are May, but the other 3 are all autumn, which is also very interesting.
Troy wants you to send some water down his way. Please.
No, that's what I'm going to talk to you. I need to get Steve and James from Tulsa offline, and we'll make a deal. We can get some cash. I got a credit card. We
there you go.
Get some rain down here. So
this man is he's willing to pay for it.
Yeah, exactly. We will send you rain because it will water up that mountain cedar and get it ready to go for you.
Oh, thank you for reminding me of that.
All right, Troy, what's your pick? Go.
We got actually a public information statement from the Weather Prediction Center last Thursday, and then got an email today from David Novak up at WWPC about the new experimental probabilistic precipitation portal. And I know, Steve, that this is something big that we have coming about, that trying to go, and Troy doesn't completely understand it, but this is a new experimental website. I think it's neat. I've provided the link for it. And if you get a chance, go take a look at it.
Indeed. We'll put the links up on weatherbrains.com. Okay, Jamie, we've stalled long enough. This has been the coolest discussion tonight.
Yeah.
And I know you got to have some cool link or something to give us. Go.
Well, I'm going to share one that's a little bit different, which is a link for a story that we just put out. And what it's actually showing is a giant laser sheet that we're using to study the flow around UAVs to better design the systems. And we're actually using a unique wind tunnel that's being developed here in the Tulsa region called a wind shaper, which uses a series of really small computer fans that can be individually controlled, which allows you to create about any kind of flow that you'd want to, gusts, shear, turbulence, by all controlling those individually. So that picture, shows some of the stuff that we do in the laboratory to be able to better understand, the flow around the UAVs and design these to really measure the weather accurately.
That's outstanding. And again, we'll put the link up on our website, weatherbrains.com. All right, Steve, we have stalled long enough. I know you got something good for us. Go.
Don't know if y'all have seen this, but it's sondhub.org. Do you know that? Where it's where you can see weather balloons in flight as they're launched. So there's folks that like to deal with radios and they can tune it to a certain frequency. Then it's put up on a server. You go to sondhub.org and you'll see where the weather service balloons are. And that's where I see Jamie's balloons. And so it'll pick up anything that's a standard weather balloon in the country. And so you can see where they've landed. You can, some of the software, you can see the QT live as it takes off. So pretty cool site. I happened to have it up and I looked over and I said, hey, there's my answer.
Now, I'm getting we're under construction.
Oh,
Please check back.
SONDE. I'm sorry, SONDE.
Oh, it's like Sond.
Sond, yes.
Okay.
Yeah, it's working great. It's a fabulous.
We lucked out on that one.
Yeah.
Be careful, James.
Yeah, that's true.
So when it doesn't have a parachute, does that mean it's down already, Jamie?
So yeah, if there's a balloon, that means it's rising, parachutes descending, and if you see the little canisters on the ground, that's where they've landed. You can click on a site, a launch site, and get either the history of the landings or the last known points anyway, or you can get a projection out for the next several days of what are potential landing sites. So yeah, click there, and then
this is
right in the middle.
Absolutely.
There you go. Generate projections or click historical. And so
Rick
Smith,
oh wow,
bombs Tulsa periodically, and so we'll see Norman balloons land in Tulsa. And I'll know Rick sent him with love.
This is absolutely outstanding. This is a time suck right here. I mean, I'll tell you right now, I'm going to be on this thing for a long time. How did I not know about this? Wow.
It doesn't take much. If anybody wants to contribute that, you need about a $25 software-defined radio. A Raspberry Pi helps to where you can basically collect the data, upload it. I've got 2 radios running, so I can see Norman's balloons and the Lamont site there in north central Oklahoma simultaneously if they're in the air together.
Yeah, the Birmingham Sond is lying on the northeast side of Carrollton, Georgia tonight.
It happens. So, Jamie, is there anything we need to plug? Anything you need to mention? Social media accounts, websites, anything before we wrap it up here tonight? It's been a great discussion.
No, I think we've talked a lot about what we're doing right now, and so I think if you look, we have some good videos on YouTube. Just search my name about some of the stuff that we're doing, and we're going to keep moving forward, and we're getting prepped for the spring storm season to be able to do some flights to be able to help Steve do better forecasting.
Well, for on behalf of all of us lowly practitioners out here, thank you guys for what you're doing. This is a big thumbs up and a big thank you. It's been a great discussion this evening. And for those that are new here, we are typically on the air Monday nights at 7 o'clock Central, 8 o'clock Eastern. And you can watch this live if you want to watch the video version. We know that most of you listen, which is great. But we do have it available on YouTube, the WeatherBrains YouTube channel, youtube.com/WeatherBrains. And but whatever, however you watch, listen, thank you. If you want to get in touch with us, send us an email. We'd love to hear from you. The address is email@weatherbrains.com. And Bill Murray, I'm sorry, I left Bill out. Bill, how did I do that?
Well, I didn't have much to contribute tonight, James. So
Well, no, it's just like normally you're leading the discussion, and you were back in the bullpen. So I totally forgot your pick of the week. Go, let's hear it.
No, James has done a fabulous job the last few weeks, and the next few weeks too. He's got Kevin Claysel coming up next week, so looking forward to that. It's good to see Steve. Nice to meet you, Jamie. Thank y'all for being part of the discussion tonight. Really fascinating conversation.
Thanks
And
for
I've
having
already
us.
put my Christmas list together, and it's got a drone on it. So I can't wait to start playing with that. I need a new hobby, about like I need a new hole in the head, but at least this one relates to weather. Yeah, James, my pick of the week are the various weather awareness week posts that our team at AlabamaWX.com has been putting up. Jack Rudden, Scott Brown, Jen Nairmore have all been putting on some good posts there. So especially if you're in Alabama, the posts apply everywhere, but the criteria are based on the forecast office here in Birmingham. But if you get a chance, those 6 posts are really cool read if you're in Alabama, because we're getting into that time of the year, James Spann.
We are. All right. So good deal. So again, we'll be back next Monday night. So on behalf of the entire WeatherBrains crew, I'm James Spann. Thanks for listening. Have a great week, and God bless.
Y'all have a great week.
Yeah.
Great
Thank
show,
you.
everybody.
That
Thank
was
you.
very
Yeah,
good.
Thank
Nice
you,
to meet
Jamie.
you.
Thank you, Steve.
Fascinating.
Thank you both.
Good
Thank
stuff.
Okay, we
Bye.
enjoyed it.
Thank you all for
That's
your
fun.
time.
Thanks for having us.
Yeah.
Okay.
Thanks, everybody.
See y'all later.